contact the network itself and parse the responses. So this is about upgrading our SDKs, PocketJS, PocketGo, and PocketPy. First of all, let's just get to know me a little. My name is Enrique Ortiz, so we stay around here at Caloque. So if you see me anywhere, just tell me Caloque and ask me whatever question you want. My GitHub and my Twitter's there. My DMs are open for everyone, so just feel free to like ping me, whatever time. If I don't respond, it's probably because I'm doing something else, but I will get back to you for sure. But let's talk about SDKs. Let's get into it. First of all, let's see the agenda. We're going to cover a few topics here. We're not necessarily going to get deep, so if you have any questions, just go ahead when we finish. But basically, the agenda is basically why we will we build a new SDK, like why we do it. We had one, and then why three? Why are we building 3 different SDKs for 3 different things, right? And then we're going to talk a little bit about each one. First one, PocketJS, and the history around it, like how we got to it, and how we scaled after we rebuilt it. Then PocketGo, basically just looking into the future and what we want to do at an internal level. And then just PocketPy and what we want to do with it. So just getting into it real quick, I want to first have a glossary, right? Because not everyone was as the previous presentation necessarily. But we're going to cover these points here, which are important terms you need to know to just get the whole history around it. First of all, it's the portal API, the thing we were talking about before, and that's just basically the service that can contact the network and get responses back. Real quick, we have a few tricks around our sleeve to make things fast, and it just provides more quality of service and preference for users, right? Basically, then we have the global dispatcher and the fisherman. The global dispatcher, again, service that refreshes all the sessions. Every set amount of minutes, I put 3 minutes. We made a change recently, but basically, we just, every X amount of time, we just refresh all the sessions, make sure that everyone's on time. The fisherman, it's basically just the V0 implementation of the spec for V1 that we are proving right now. Basically samples all the relays and performs quality service checks, and then samples based on latency with the cherry picker later, right? And then a session, which is the most important thing. The session is just the pairing of an on-chain app with a number of nodes. Right now it's 24, and the lifecycle of session, every 4 blocks, a session is renewed. That means that every 4 blocks, every 1 hour, you get a different session with different nodes. And they're global, of course. So let's get into it, right? Why does Pocket need an SDK, right? We're a simple chain in a lot of ways, right? We're very application specific. And in general, we just like do servicing, right? So why do we need an SDK? Why don't we just build like tool for node runners and that's it? But the thing is that Pocket has a healthy ecosystem of products sitting on top, and they need shortcuts to get there, to get to market just faster in general. It make things simpler. Basically, SDKs allow you to get data from the chain easily and not have to like handwire a lot of code so that you don't have to like parse these responses and know all the types and know all the nitty-gritty details of the chain. That is all abstracted away into an SDK with utility functions. Also, it allows community members to build products on top. A very good point, a very good example, for example, is wallets. We have this wallet, the Pocket Wallet, which is a community effort that was released soon, and it's actually built with the new SDK, so shout out to them. And then we have things like PocketScan, which build their own tools, right? And at some point, I know they use their SDK, and then they just basically have their own host suite of tools now. Then it allows app developers to integrate directly, which, when self-staking is live, when you can actually use your coins on the portal, this will be important. And on top of all, it gives node runners more options for writing tools. I know you guys like Bash. I don't. So I want to give you the option to build things in like JavaScript and Go, It's nicer. Trust me. So, with that gone, you may be wondering why we rebuilt our SDK, because we had one. Let me tell you a story. Basically, we were facing a lot of issues because of the growth in Q3 and Q4 2021, right? There we were having a lot of 2x months, like we went 50 million, 100 million, 150 million. We went to 300 million, and it was crazy, right? Every single month, we just doubled the amount of relays to a crazy amount. And from the community, everything was great. Internally, we were like, guys, what are we going to do with this? Because we had a very big elephant in the room, which was this, the session rollovers. So you know that the session every 4 blocks gets refreshed. So in a way, this was our killer problem, because the problem really is that due to P2P network latency in the nodes, and due to just like nodes just not being allocated the right amount of resources, right? Some nodes were just really slow refreshing sessions. And of course, at that time, our infrastructure just takes over, relays go to altruists, and then once the rollover finishes, everything is fine again. That's okay. The problem is, like, this time, this graphic just shows how it looks. Right now, like, that graphic looks great because it's like 30 seconds and that's it. And especially in the one with faster block times, it shouldn't be really an issue, but at that point in time, we had like 5 minutes of rollovers and more, which was like crazy, right? And then this just cascaded because then we had some other problems, just like we needed to prime an endpoint, just send some relays to make it fast, right? And customers noticed this. Like, customers really were asking, like, why is my endpoint slow before I send a few relays, right? So we basically just had to find a solution. We optimized a lot of things, but really the cause was in SDK session handling from the old SDK. We tried to get around it. We tried a few solutions, deployed them. Nothing was working. We always faced dead ends. So at one point we said, whatever, we're going to remake it. Then we had additional reasons. Like Q3 and Q4, again, it just meant that we just had to trim the fat in general. Like, we had to optimize our stack. Like, that's where we came up with things like just like having sidecar Redis and all that stuff, globalizing the checks. Like, our wish list was growing by the day in Q3 and Q4, and in Q1 we got down to it. And then we needed a more flexible and easier to use SDK, right? This was from feedback from the community. People were like, I like you guys. I like the SDK, but I wish it did this. I wish it did that. And then we had some integrations, right? Enterprise integrations that were like, no, we want you to do this. We want you to do that, right? And we had to respond. But then the thing is that the SDK wasn't really our responsibility. It was the protocol team responsibility. But we had to take it over just because we needed to move faster. Because protocol is focused on V1. So if you want to know about V1, they'll tell us about it tomorrow. But basically, it ended up in the classic, we need ownership of everything that we do, right? We need to optimize our stack. We just need to be fast. We need to trim the fat, get latency as low as possible. That means that we need to be able to just like, whatever we feel is wrong, we need to be able to change it. So we just decided to own the SDKs. So basically, we set out to build a new one, and then 2, and then 3, for several reasons. First of all, let's talk about PocketJS. I call this unlock and scale, because in a way, just building the new one allowed us to just have several scaling strategies to then bring the billion relays that you saw this past week into the network. But basically, PocketJS, like one of the main objectives is that it's slim by design, and that means that it's just lighter, has less dependencies, which is better for supply chain security. And in general, we just take very seriously the fact that not everyone has just good internet. And I mean, I know that because internet here could be better. But basically, it's just smaller, and that means it's also easy to use in a lot of ways. Also, it's more modular and more composable. This was like kind of a wish list internally for us because we were like, we could probably architect this in a better manner that's easier for people to use and gives better DX, right? And basically, that means that going from a monolithic package, we decided to just make it modular. So it's 4 packages and a few optional ones, if you'd like. And also wanted to make it more flexible. That means that we really believe that sensible defaults are what people want. Like, people do not want to fiddle with like configurations and stuff. But for the people that do, we need to provide options. So we just try to not compromise too much, but still, give options to people, right? And so let's get into a few parts of PocketJS along with some examples. I'll share the slides later so you can check it out. And also, the repo is available, so just use it. But basically, it's provided, as I said, it's divided in 4 packages. This is the first one. This is the main one, the provider. The provider is just like basically taking over the just the main PocketJS library functionality that lets you connect to an HTTP connection, let's say a node or a portal endpoint, lets you connect to dispatchers, and also lets you, just get data from the chain, parse responses, and just talk with nodes in general, right? It has two flavors because we needed them, and this is a cool story as well. We have the JSON RPC provider, which is node only, right? And we have the isomorphic provider, which is compatible with browsers. Why the difference? So basically, for the new SDK, we made the JSON RPC provider first because we wanted it to be fast. We wanted to just make sure that this thing is fast before putting it out. And so we went out and basically saw, in different benchmarks that we spent a lot of time just parsing responses in general. And we were like, we can probably fix this. We can probably make this faster, right? So we went out looking for a fetch client that wasn't too big and that wasn't gonna put a megabyte into the library, right? And so we came up with using Undici's fetch implementation. Undici is Node.js internal fetch client. They have, basically it's a request client, but it has a experimental fetch implementation that is actually 25 to 50% faster on their benchmarks. And we proved that by shaving off a millisecond or two of response time by using this, which is really cool. And while it's Node.js only, we still provide the isomorphic provider so that if someone wants to use a provider and get data from the chain, from the browser, they can. And of course, I said that PocketJS, the new one, is very slim, and we mean it. Bundle phobia, if you don't know about it, lets you know the size of the packages that you're gonna download from NPM. And it basically just compiles them and tells you how much it's gonna wait minified and then gzipped. And so basically the provider is just 20 kilobytes, minified, gzipped, it's 5 kilobytes. So yeah, it's pretty slim. Then we have the signer, which is basically the most sensitive package in a way because it needs to be completely backwards compatible with the old one, right? You need to be able to import private keys, PPKs, and all that stuff without just giving people any other format. And also just provide the key management functionality, right? Because we wanted to use it in our products as well. So we made that. It's compatible again with portable private keys and raw private keys. So whatever file you have from the old PocketJS SDK, you can use it there, no worries. And you can sign arbitrary messages with imported private key. That means that, of course, if you want to do message signing, you can. And then bundle phobia stats. This is the biggest package of them all. It's 362 kilobytes, but basically that's because we need to include a non-tree-shakeable cryptographic library that we basically just cannot get rid of, right? But of course, over time, we expect the compatibility with ED225, 519 keys to just improve, and in general, just get lighter over time. And it's still an improvement over the 2 megabytes old key-based module in the legacy PocketJS. So we're still doing well, right? And then it's still 5 times lighter. So yeah. We have also the relayer. This is the package that Ronnie likes the most because it actually makes the whole thing work. It allows sending relays into the network and obtaining new sessions. The big difference is that the old PocketJS SDK cached these sessions, this new one doesn't. That's up to the user. And while in a way you can say, hey, that's a UX downgrade, it really isn't, because the reality is that for most of the products, if you're doing relays, you probably know how you want to cache the sessions. Because in a way, if you see how we do it, because we need to scale, we do a lot of tricks to do it, right? So just catching things in SDKs isn't really enough. However, yeah, it composes with the provider and the signer to leverage the functionality, and basically only needs to include basically all the cryptographic functionality and data structure types to construct what it needs to send a relay. It has built-in data types for each parsing. We use that a lot on the portal API. So we know either it's a Pocket not failing, are we failing to connect, or is it timeout errors? And that has really helped us just track down issues wherever there's something failing, if there's a node provider that is having an outage, we just find out really easily about it because of the errors. And if we have some kind of like infrastructure thing going on inside, we also notice pretty fast as well. And then it's also extensible through injectable constant parsing logic. That is a mouthful, but let me explain. Especially if you integrate really different chains in a way, let's say like Arweave or Filecoin, their responses aren't really that standard in a way. So basically, you might want to have like extra checks if something is actually like valid or not, right? And so that means that you can basically just inject a function with all these checks, and then we do our checks, our normal checks, like if it's JSON payload or whatever, and then we just return the answer back to you. And of course, more bundle for you stats. It's minified 37 kilobytes, gzip 12 kilobytes. And as you can see, it's way easier to send release this way, instead of like a whole page of just like boilerplate code. And then we have the transaction builder. The transaction builder tends to be really important for the community because they want to send transactions. They want to sign transactions offline and all that stuff. But basically, this package, of course, lets you send transactions, sign them. You can sign them offline, which is really important, let's say, for exchanges, because they usually just have services that do this or that they need to wait for confirmations before doing things. And so we provide the functionality for that. And we also really improved the payload validation from the old one as well. And of course, more bundle for view stats as well, if you're into that. But basically, gzip is only 25 kilobytes. And as you can see, like just sending a transaction here, it's just a few lines of code. Now, the supporting packages, or basically the optional ones, that'll be basically the utilities package that we use basically for functionality like getting a public key from a private key or an address from a public key, which are things that everybody that deals with addresses needs to do at some point. So we just basically standardize it and put it there. And the PocketJS abstract signer and provider, which implements the abstract class you need to make a relayer or make a provider. And what that means is that if you want to just roll your sleeves up and just get into it and make your own thing, you can. You don't need to use our implementation. We provide the blueprint so that you can do it yourself if you want. And that means that you can implement custom functionality on top, right? And then we have the types library, which basically just gives you everything you need to interact with the chain. So now let's talk about the important part. Was this impactful? Like, sure, we rebuilt the library, we think we improved the UX. That is all really important, but in our case, we really just wanted to like make the portal API scale. So was it impactful? And as you can see there, I took this screenshot when we actually got to 1 billion relays. This is from Datadog. So yeah, I think it was. Because in Q1 and Q2, we really scaled up our infrastructure. Basically, it let us make the network faster. And what this means is that the session and fetching and caching separation, which for me was really like the biggest thing, it just let us do things like sidecar Redis and have like regional Redis and just do all these tricks just to make things faster and therefore scale. We unlocked V1 experimentation. We were like, especially at our last offsite with the protocol team, we were like, we need to experiment with the V1 concepts to just prove them ahead of time and make sure that they work properly so that when we go to prod with V1, it's all just like very well proven, right? So that's exactly what we're doing with software like V0 Fisherman for quality of service. Because again, with the caching separation, we could do it, so we just went ahead with it. And also, we'd unlocked scalability, because again, it let us do all of these external services, the global dispatcher, V0 Fisherman, and now the Cummings cherry picker separation, along with the database. And so with this, we can just like ensure proper quality of service for V0, and then just prove concepts for future implementations. So I would say it was kind of a success. However, also again, probably talking too much. Let's see some numbers. We made this benchmark a few weeks ago already, so it's probably better by now, but basically we made this benchmark with a tool called K6S, which is like a load testing tool that also helps with testing just Response times and whatnot, we did it with 50 concurrency, as you can see there. We're comparing the Pocket free tier, Alchemy growth tier, Inferior team, and Builder. We had some other service providers as well, but they were rate limiting us. So I guess we're too fast, but let's get down to the numbers. As you can see, in the median latency, which is really important thing here, we're actually almost twice as fast as everyone else. That means our median latency is really, really good. And so we actually can compare it to the centralized providers. About our P80 latency, that's where we're lagging behind a bit. But we're improving, and we're still like just making the cherry picker nicer and better and just tighter so that the P90 latency improves. But basically, you don't need to sell Pocket as a decentralized but probably slower service provider. We're just as fast but more decentralized. And we're keeping being more decentralized. But where does PocketGo fit in all of this? Because, you know, it had a big part to do with it. So let's find out. So basically, first of all, PocketGo is just another library, another supported SDK that we make, that we maintain by us. So that means that if you want to go to GitHub and like post an issue or do something, it's there, it's public, and you can use it. And then the main thing is that it powers the supporting quality of services of the Portal API. That's mean Featureman, V0, Global Dispatcher, and basically everything that is going to be using Go, right? And then it borrows as much as it can from Pocket Core V0, of course. That means like transaction signing, types, and more. They're written in the same language, so why not do it? Why not save us some work, right? And of course, the most important thing is that it has feature parity with PocketJS. So that means that if you want to use it, like instead of using JavaScript, you want to use Go, you can just go and use Golang because nothing's missing. But why make it? Basically, we've been feeling the pains of like the Portal API in general and our Node.js services just being single-threaded. Like I had a lot of conversations with Ronnie where he will be like complaining about Node.js just like being annoyingly slow in the event loop. And I was like, it's not that bad, but it really was at some point. And also, Go concurrency model just fits us perfectly, right? Go's made for really distributed concurrent systems, and we reached a large scale. So it makes sense for us to migrate to just use a faster, more concurrent, bot-assigned language. Also, we want to make our stack easier to deploy, and if you deploy a Node.js application in a custom manner, you know that it's not necessarily as easy because things might break, dependencies might break, and in Go, we just have more supply chain security. And also speed, right? The reality is that latency is the name of the game here. Microseconds matter. And that means that if we move to Go, we'll probably improve by a little bit. So yeah, we care about the stuff. So that's why we did the PocketGo. Now, the impact of PocketGo, again, the session rollover graph. But this is how we really got in with control, right? Pablo did PocketGo. He made a great job with that. But basically, we then could make Fisherman, V0, and Global Dispatcher to just really get a hold of like session rollovers and just like then all the other problems that were cascading, right? We then could tighten the cherry picker and just like improve our scaling strategy. Then also our stack just is more concurrent by default. We take more advantage of like actual concurrency instead of just like having to like pay for more instances and just having less costs in general, right? We can leverage the faster runtime, and we enjoy the concurrency of Go. Also, it's more it's our default tooling for like new systems and new software in general, right? So whatever we do internally, if it's a backend thing, it's probably going to be done in Go instead of in Node, right? So that was all pretty cool. So what about PocketPy, right? I haven't talked a lot about it, but the reality is that PocketPy is an internal experiment. We're taking our time with it, but basically there's more to it than relays and transactions, right? When we were making PocketGo, PocketJS, we were really focused on like how do we make this really user-friendly, really just nice to use, and also how do we make our things really fast? And then when it comes to PocketGo, it's really more about how much can we borrow from Pocket Core, and then also how we can ensure that it is, you know, just faster in general, right? But in the meanwhile, we were having community members that wanted to build indexers, that really wanted to parse the chain really easily. So again, BlockJo, that Alex mentioned in the keynote earlier, basically he just wrote PocketPy on a weekend, and then from there he's maintaining it. And we're using for data experiments and just like indexing internally. And so basically our vision is to let community members just inspect the chain easily apart from using a GUI. It's focused on getting and parsing data from the chain, and that means that, of course, with the minimal indexer library that you can already use, and then with PocketPy, once it's finished, you'll be able to do this much more easily. And again, an internal experiment for now. We're going at our own pace. However, that's a lot of talk. My presentation is kind of short because I just wanted to tell you a little bit about the SDKs, but what about the community? Why, are we listening to them? Do we really want to improve the DX, or did we do this for ourselves? And the reality is that our main drive for really just remaking the SDKs and making it nice was because community members just wanted something nicer to use. The PocketJS, the legacy one, was great and it served us well, but we could really just step it up for the community. So in that case, we also got you covered because we've made sure all of the packages are properly documented, right? For PocketJS, everything is full of JS doc. I think I've spent more time documenting things than actually making them. Just to let people learn well how the chain works by using PocketJS. Our repo has info and docs that you can read on how to use the thing. And then for PocketGo, of course, the internal Go documentation has you covered, right? We're receptive and we respond to GitHub issues. And what that means is that you can go on GitHub, right? You can send us an issue, just like Ronnie said. And we'd really love if you get involved and you send PRs or you open up an issue. I've already had a few community members come up and tell me, hey, can we fix this, or can we make this a little bit better? I have some ideas, and that's been just really great because we really want to be more open to the community about these things, and we really just want to make an effort to just let everyone have an opinion, and if they want to get dirty, they can, because all the code's open source in the end. And again, also, my DMs are open, so just feel free to ping me anytime. And also, we're focused on providing a great DX. And it means that, for example, we're constantly revisiting things in PocketJS, tweaking things so they have better defaults, and also just providing quality of service updates. And with PocketGo, we're also improving it, making it easy to use, and just in general, just making it nicer. And so with that, I want to say thank you for coming. Let's definitely take some questions. But basically, you have the repos there for PocketGo, PocketJS, and when PocketPy is public, we'll definitely tweet it, and we'll let you also get into it as well. And thank you. Alrighty, so any questions? Go ahead. Sorry, the what? When will PocketPy be public? As soon as we really get around it to finish it, Joe's working on it. It shouldn't be really more than a couple of weeks in general. It probably won't be super complete, right? I don't know if we're gonna integrate transaction signing functionality. We probably should. But in general, we wanna make it public ideally over the next month to just let people play with it. Yeah, so Alex will tell you about it in the next presentation. He's going to get really deep into it. But basically, again, we use the load testing tool, and we spinned up a few servers everywhere. And so basically, just ran the load testing tool to just see how it performed. We do this checks actually quite frequently, every few months, right? To just see how we compare and if we are actually improving, and if the network health is actually improving in terms of servicing. But Alex will tell you more about it. Don't want to spoil the details. Alrighty, more questions? Yeah. Is this information you talk about available? Right, so the benchmarks, you mean? Oh, okay. So the metrics so the metrics we run for the service, like, no, we really don't have it saved, but like the actual latency, like we record things to several metrics databases. Again, Ron is working on like exposing a few of these for the cherry picker. We already have an error database that people can query, and also like just the distribution thing that the traffic research Alex talked about. But we're basically just like slowly opening up all of these things for the community. We would love to just like open up things such as Influx that hold all of the data and all of the traffic, because it's good for everyone. But especially when dealing with time series databases, they fall over quite easily. So we're just going really slow with it. Oh yeah. Yeah, that's a big one actually, because we use Datadog internally for basically everything. That's how we track things. That's how we like just uh, track bugs everywhere, because we can see it in the traffic. We basically know, okay, AP Northeast is having issues. I know what it is. But the thing is that for some reason Datadog can be a little bit slow sometimes. We had a kitchen sink dashboard, that's how we call it, that has everything, that we wanted to share with the community, but as soon as the internal company opened up the whole thing, it got very slow. So we're trying to find ways to just like relay these data out of it. Yeah. Any more questions? Yeah.
You mentioned you saw a lot of benefits from those parallelizability over Node.js.
Yeah.
So kind of, could you just mention, like, was it just Go channels that you were using, or?
Yeah, just really we're just really like nothing really fancy. It's really just using the synchronization primitives and just normal channels, wake groups, and basically all the built-in stuff. Nothing crazy like a Musex or something. We don't need that. You guys probably do in protocol, but overall, really, the main improvement is that we get away from the event loop model from Node.js that can sometimes just drop promises and drop database writes, because it just doesn't want to process that, and just really take control of what's happening with Go routines. That's basically has been like the biggest thing for us.
So other developers building other SDKs, would your recommendation be to start with like Node.js or go straight to Go?
I would say, because we have options, use what you feel free, like use what you prefer. However, of course, as an engineer, I'll tell you, if you're dealing with hundreds of millions of relays, you probably need to think about scale, and I would probably choose Go, PocketGo, because that's what we use as well, and that's what is working for us. However, PocketJS, this new one, with a few tricks and implementation and just like optimizations, you can also use it. Any more questions? All right, thank you then.